Good day. In this module, we are going to discuss on equation of circles. What are circles? Circles have a single constant radius around a center. Alright, circle and their various properties such as the radius, diameter, circumference, and area have applications in real life. In this chapter, we will find out the standard and the general equation of a circle in a Cartesian plane and how to interpret its equation. Let us look at page 108 of your notes. In activity 1, let us look at case 1 in the page. You see a circle drawn on the Cartesian coordinates on the left of your diagram. Now, if I have P as any point on the circumference of a circle, with center 0, 0 and the radius known as R, I know that CP, essentially the length of CP, is actually equals to R. Now, if I look at the right-angled triangle CPQ, if I look at the right-angled triangle CPQ and I map it with Pythagoras theorem, all right, we will know, number one, the length of PQ is actually Y units. We will also know that the length of CQ is actually X units. Now, if I use Pythagoras theorem, I will know that R square is actually the same as X square plus Y square. All right. Similarly, what if I shift this right angle triangle away? Now, look at case 2. Right? I know the length of R in this case, all right, is the length of PC in this case is R units. If I ask myself, what's the height? What's the perpendicular height? What is the length of PQ in this case? It is essentially taking Y minus away 3 units. Why 3 units? Because we know that the distance here is actually 3 units. And the whole distance is actually Y units based on the coordinates written here. Based on the coordinates written for P and based on the coordinates written for C. Now, if I look at the length of CQ, now I know this entire length is X units. And I know this bit here is already 2 units away from the vertical axis. So essentially, what is your CQ? CQ will therefore be simply X minus 2 units. So if I look at what is R, R therefore is as good as, or rather R square is as good as X minus 2 square plus Y minus 3 square. Now let me shrink the page a little and do a comparison between case 1 and case 2. Now, in case 1, we had a circle, all right, and the circle had a radius CP. All right, CP is the radius. We can then therefore say that the radius square is actually the same as the perpendicular height of the triangle that is formed, Y square plus X square. All right, even if I shift the center of the circle, as in case 2, I shift it slightly, it is still no doubt that R square is still possible to be found if we have that right angle triangle. In this sense, Y minus 3 square plus X minus 2 square. So what I'm trying to drive at is, if we want to find the radius, all right, in fact, we want to find equation of a circle, it can be formed by considering the right angle triangle inside. So we know that the radius is essentially the vertical height square plus the horizontal length square. As you can see in the next page, this is the generic formula of equation of circle in standard form. Moment we have our center And also we have the r. We know that the r square is given by x minus a squared plus y minus b squared. Let us use the examples in the following table. Now, knowing the standard form of equation is always written as something square plus something square equals to r squared based on Pythagoras theorem. Over here, for a, x squared plus y squared equals to 9. We can rewrite this as x plus 0 square plus y plus 0 square is equals to 9. Or for that matter, I can change this to 3 square. From this, therefore, we can see that the coordinates of the center is essentially 0, 0, and then the radius of circle is just 3 units. Note, in B, x minus 1 square plus y minus 3 square equals to 16. If I were to write this as your equation of circle given to you, you can then therefore conclude that your coordinates of the center of the circle is just 1, 3. Remember, please note the sign. The sign, this is negative. This is also negative. So therefore, when you write them down, it will then turn positive. Remember, this is x minus a, this is y minus b. All right, and the radius of the circle, therefore, is 4 because square root of 16 is 4. So for C, x plus 2 square plus y plus 4 square equals to 25. Just by looking at the 2 and the 4, we know that the coordinates is negative 2, negative 4 for the center of circle, and the radius is 5 units. Looking at part D, x squared plus y minus 5 square equals to 1. It can be written as x plus 0. So we know the first coordinate, the x coordinate is 0 already. This is y minus 5. Therefore, the y coordinate of the center is 5. And then radius is 1 unit. For part, refer to your question, you will see that x minus 1/4 square plus y plus 1.5 square is equals to 4. Therefore, for this one, your answer should be, for center of circle, should be 1/4. And then this is positive 1.5, therefore it should be negative 1.5. And then your radius of circle is 2. So if given a question like this, take the coordinates of the center and the radius of each of the following circle. If I look at question A, it says x minus 2 square plus y plus 3 square equals to 25. I can therefore conclude that the center is 2, negative 3. The radius is actually 5 units. For part B, where your question is x plus half square plus y square minus 49 equals to 0, I can rewrite this as x plus half square plus y plus 0 square is equals to positive 49. All right, therefore, my center is negative half. Be careful, be careful, be careful of the sign. Negative half 0, and then I will know that my radius is essentially 7 units. Vice versa, if I'm given the center and I'm asked to write the equations now, I'm asked to form the equation now. In part A, I know center is 2, 3, radius is 5. I can therefore form equation of circle. In this case, all right, you will get x minus 2 square plus y minus 3 square equals to 5 square. X minus 2 square plus y minus 3 square equals to 25. B, for the equation of circle. I don't think this is going to be tough. You will know that it is x. It should be x minus -1, so x plus 1 square plus y minus 3 square equals to 4 square, which is as good as your x plus 1 square plus y minus 3 square equals to 16. Some of you may ask, do I need to expand it? Do I need to simplify it further? The answer is no. You can just leave your answers as good as this. All right, you may choose to leave your answer in this manner, as in the first line, this one, or you can choose your answer by you can choose to leave your answer by expanding the numerical term. Either way, it is acceptable. All right. Then in part C, again, equation of circle. All right, since it's an equation, let's write it down. It's x minus 4 square plus y plus 2 square equals to 7 square. So for some of you, you may want to put it this way. Either way is fine.